Okay, so lesson 5.2 moves on to systems of equations. So we start out with a couple of like word type problems and write an equation and kind of solve it that way. And then there's a few where you just need to solve a system. Okay, so for this first one, it says a fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? So the first thing I would do is make a equation for how much they're gaining. How much is that designer going to gain? How much are they going to make money-wise? And then I also want to know how much are they going to lose. So they're gaining money by selling them. So Adeline, can you answer that, please? Sorry. Okay, so how much are they gaining? They're gaining money by selling the hats for $12.50 each. So every hat, I'm going to call X my hats, and Y is the profit that I'm making off of those hats. Okay. And then how much am I going to lose? I'm going to lose money by buying the materials for $5.50 each and by advertising. So their $5.50 is per hat. And then the $1,400 is just overall $1,400 that I'm losing on advertising. Okay, so there's those two equations. Then I want to know, when am I going to break even? I would break even when these two sets are exactly the same. So when does 1250x equal 550x plus 1,400? So I would subtract my 550x. That would give me 7x equals 1,400. And then divide by 7. I would get 200. So remember, X was the number of hats, right? So that means I have to sell 200, or the designer has to sell 200 hats in order to break even. Okay. The second one, you have a jar of pennies and quarters. You want to choose 15 coins that are worth exactly $4.35. How many quarters and pennies will you have? So I would start out first with the fact that I have some coins, and total I have 15 of them, right? So I'm going to start out with the number of coins that I have. I know that I have some pennies, and I know that I have some quarters, and total there's 15 altogether. The other situation is, how much is it going to cost? How much money do I have there, right? Not how much is it going to cost. How much is it worth? Sorry. So the money equation in this case is, how much is a penny worth? Well, a penny is worth, I'm just going to write it as 1 cent. So I'm going by cents here, okay? So 1 cent per penny and 25 cents per quarter. And I had $4.35, but I'm not going to write that as 4.35. I'm going to write it as 435 cents. That way everything is in cents. If not, I would have had to put 0.01, 0.25, 4.35, and I don't want a bunch of decimals. So I basically just move the decimal over 2 places on all of those. Okay, then I'm going to try to solve this. So the method that I would use here is elimination. So I would look at this and say, I'm going to line these up. I'm going to change all of the signs in this top one because it's small. All of those are smaller than these values. And that's going to cancel this one out. A negative p plus a p gives me 0. So the pennies are gone now, and I can just focus on these quarters. So 24 quarters, because this is minus 1, 25 minus 1. And then 435 minus 15 gives me a 420. And then I'm going to divide by 24. Now this is not going to come out good though. So 420 divided by 24 gives me 17.5. So why is that not good? Because I got an answer. Well, that's not good because it tells me how many quarters I had. That means I had 17.5 quarters. That's not possible. So in this situation, this is a oh, what did they call that? It's not a, I want to put not solvable, but it's not a viable, not a viable solution. So instead of not solvable, because that sounds really idiotic, not viable is the better way to say that, meaning this isn't possible. Like I can get an answer, but the answer doesn't make any sense, okay? So this is not a viable solution. That won't happen too often. Okay, example 3. Let's just look at a few more ways to solve these. So here's one equation, here's another one. This top one, the only variable in that top one is a y. So I'm going to go ahead and solve this one. So 7 equals 2 minus y. Let's minus 2 from both sides. And then divide by -1. So y is -5. I already have part of my answer. Then I can plug that in, use substitution there to solve the other one. So x minus 5 now equals 8. Instead of plus y, it's minus 5. Add your 5, x equals 13 then. So the other thing is, how do you write your answer? You could write it as 2 separate answers, but most of the time you're going to see it written like this, especially if it's multiple choice. 13 comma -5. So x comma y. That's your answer. Okay, this one, again, I would use substitution. So both of these equations have x and y values. They both have an x and a y. The other thing, it's not set up like this one was, where my p's were lined up, my q's were lined up. In this case, I've got my x's lined up, but these are not both y's. So it's not really set up for elimination very nicely. So I'm going to use substitution. I know that this equals y. That means you can plug it in for y. So my new bottom equation is going to be this. Instead of y, I put x plus 3. So I'm going to distribute. And then I'm going to simplify. So this would be 7x. And if I minus my 12, I end up with a -5. So x equals -5/7, which is kind of ugly, but that's okay. And then I'm going to plug that back in up here and solve for y. So a -5/7 plus 3 gives me my y value. So if I'm at -5/7 and I add 3, that's a positive 2 2/7. So that means my answer in this case is -5/7, comma 2 2/7. You also could have written this as an improper fraction. So 16 over 7 would have been 16 over 7. Either of those are fine. All right. Example 5, this one is set up for elimination really nicely. So the A's are lined up, the C's are lined up. So I'm going to do like I did in that other one and just make everything on top negative. So I'm changing the sign of everything on top. That will cancel the C's out for me. So then I have 2.5 minus 1. That's going to be 1.5. A equals 164 minus 101. That's 63. And if I divide by 1.5, 63 divided by 1.5 is 42. So then I just got to plug it back in and find my C value. So I'm going to go back to my original equation up there on top, which was A plus C equals 101. That one was pretty simple, and I'm going to plug that one in. So 42 plus C equals 101. So that means C is 101 minus 42, which is 59. So that means my answer on this one is 42, 59. If they give you variables other than x and y, they should still go in alphabetical order. So A, C. Okay, this one is also set up nicely for elimination, my x's, my y's, but the numbers don't match up. So if I were to just subtract all of these or subtract all of those, it's not going to cancel out. It's going to be some other answer. So I have to multiply first. Usually what I tell people is pick a variable. So let's say I pick my y's. If I want those to be the same, I can multiply them times each other. I just got to do the whole equation. So I can take 2 and multiply it down here, and I can take 3 and multiply it up here, but I need one of them to have a sign change, because I need, if that means this is going to be 6, this would also be 6 unless I made it a minus, so this would be negative 6. 6 minus 6 is 0, so that's where it's going to work. Okay, so I'm going to rewrite that. So this is 9x plus 6y equals 3, and this would be a negative 8x minus 6y equals positive 4. Now I'm going to combine these. So this cancels. A 9 and a negative 8 is a 1x, or just x, equals 7. Then I'm going to plug this back in. So let's say I pick this top equation. So 3x plus 2y equals 1. I'm going to plug this in for x, because that's what x is. So 3 times 7 is 21. Minus my 21, that gives me a negative 20. So y equals negative 10. So my answer in this case is 7 comma negative 10. Okay, last one, let's just get one more in. This is kind of a weird one, it could happen. So let's say I want to get my x's the same here. That means I'm going to multiply all of this times a negative 2 so that it cancels out. I want it to be negative. So that means I have a 2x plus 6y equals 18 on top. Still, I didn't change any of that. But this is now negative 2x minus 6y equals negative 18. Well, that is a really weird problem, because what happens is everything cancels out. So that means 0 equals 0. This is one of those weird cases. There are 2 different weird cases. One of them is infinitely many, one is no solution. This one, because they ended up the same, these 2 are equivalent. That is infinitely many. So there could be an infinite amount of solutions. You could put anything in for x and y and it's going to work out. If I come up with 2 things at the end that are not equivalent, so 2 equals 7 maybe, that's no solution. Okay?